Hello everybody. Today I'm going to go over the number blocks. If you remember, I had introduced those briefly to you, and so now I want to give you some activities and some ideas that you can do with them. And so, as you know, I had uploaded the pattern for the number blocks to the module, and then what you can do with those is you can get some tag board and then trace them on there and then cut them out. And so what I've done here is I've taken the tag board patterns and then I've made some foam pieces with the numbers. So what I've done also is match them up with the other regular size numbers so that they can see, the numbers are going to all be the regular size, but for this activity we're going to use the value block numbers. So we're going to do some addition problems, and here we're going to do 2 plus 7 first. So I'm going to get the 2 and the plus and the 7. 2 plus 7, and then we're going to say equals. So if we have 7 and we count on 2 more, 7, 8, 9, so that's going to be 9. So 2 plus 7 equals 9. So here's our number sentence. We don't have our answer in there, but we can add that. And we have a way of checking to see if 2 plus 7 equals 9. And that is, we're going to take the 2 and the 7, and we're going to stack them. And to show that it equals 9, we're going to see if it's the same height. And you can see that it is the same height. So we know that 2 plus 7 equals 9. Okay, so 2 plus 7 equals 9, and now we're going to do 4 plus 5 and see what 4 plus 5 equals. 4 plus 5 equals 9. Now, is that right? Does 4 plus 5 equal 9? Let's see. Bring the 4 down here. Line those up. And yes, they're the same. If you add the 4 and the 5, you get the 9. So that's how we check to see if we're right. So when we're using these number blocks, they're not showing the individual pieces, but they're showing the larger the size of the number, the more the value of the number. So this is just a great way to practice and check with a visual. Okay, so our next problem is 8 plus 1. So we'll get the 8. And then the 1. We're going to put that on its side here. And that goes like that. I'm going to put it here. And does that equal 9? So now we're going to check and see. 8 plus 1 equals 9. So we have our way of checking there. And our last one we're going to do is 6 plus 3. Let's put our 8 back. And our 6 plus 3 equals 9. Let's see. Step that up. Yes, we see that 6 plus 3 equals 9. So now we can make actually a visual of how all of these sums equal 9. So we see 6 plus 3 equals 9. And then we have our 8 plus our 1 equals 9. And we have 4 plus 5 equals 9. And we have our 2 plus 7 equals 9. So you see here, what we're doing is we're getting all the sums of 9. 4 plus 5, 8 plus 1, 6 plus 3, 2 plus 7 equals 9. Now be careful that when you do something like this that you always bring it back to the actual number of items so that they'll see 4 is 4 distinct items, 5 is 5 distinct items. But this is a great way to help them visualize and play around with the numbers to get the sums. Okay, the next thing we're going to do is we're going to make 10. So you see the number blocks, there is not a 10 because these are all just the single digit numbers. But just as we went over in our last video, that whenever we have a 0 in the ones column and a 1 in the tens column, we have 1 more than 9, which is 10. So we're going to try and make 10 all the different ways that we can. So what two numbers together will equal 10? Well, if we take the 9 and we add the 1, 9 plus 1 is 10. What about if we take the 6? Well, really we could take any number and see 6 plus what is 10? 6 plus 4 is 10. What else can we do? How about if we use the 7? 7 plus 3 is 10. What about if we use the 8? Okay, 8 plus 2 is also 10. What about if we use the 5? Oh, 5 plus 5 is 10. So here we have lots of ways to make 10. Now, what if we had started with the 4 instead of started with the 6? We put the 4 up here. Then we do 4 plus 6 is also 10. So that's the commutative property, that 6 plus 4 is equal to 4 plus 6, which is all equal to 10. So if we do that same thing with the 3, we know that the 3 plus the 7 is equal to the 7 plus the 3. And then we can do the 2 plus the 8 is equal to the 8 plus the 2. But see, this 5 plus 5 is still going to be 5 plus 5. So then we have all of these different sums. 2 plus 8, 4 plus 6, 9 plus 1, 6 plus 4, 7 plus 3, 8 plus 2, 5 plus 5, 3 plus 7 are all equal to 10. And that's what we want them to learn, how to make 10. Okay, now we're going to do some subtraction with these. So let's try 9 minus 3. So if we're doing 9 minus 3, we want to see what is the other part here of 9 that will be left if we take away the 3. So if we want to match these up, we can see that if we put a 6 here and we had a 9 and we took away a 3, then we would have 6 left. Because 6 plus 3, if we want to do 6 plus 3, 6 plus 3 equals 9. 6 plus 3 equals 9. doing it. I can do 6 plus 3 equals 9. So if I take away 3 from the 9, 9 minus 3, I'm going to have 6 left. So 9 minus 3 equals 6. Okay, see, this is doing fact families. These three numbers are a fact family. I can take the 9, subtract a 3 and get the 6, or I could take the 6 and add the 3 and get the 9. And again, beyond these, you want to actually use objects to teach this concept too, but this will help them with the number and the symbols. Okay, so let's take our next problem, which is 7 minus 4. So we'll take our 7 and we'll subtract 4, take away, and we can sort of see what that's going to be. So 7 minus 4, and then if we see that, 7 and 4 is 4 plus 3 is 7, then we can see that 7 minus 4 is 3. Now if we switch these and we did 7 minus 3, we can get 4. Now how do we do our check? We'll see if we add these two together. If we take the 3 plus the 4, we get the 7. And so, or we could do 4 plus 3 is 7, and we can even stack them like this. 3 plus 4 equals 7. And you can see the heights are the same. So again, we can switch this around, and then we can do 7 minus 3 is 4. And there you have that fact family. So you can continue doing this with the 8 minus 5, the 6 minus 2, 7 minus 3. Actually, we do have 7 minus 3. And have the kids learn about the meanings of the symbols.